Young people, welcome back. BNB in the house, taking care of Chapter 8, Lesson 5, using the distributive property. So our learning objective, guys, looks like number 1, use the distributive property to factor polynomials, and number 2, solve equations of the form ax squared plus bx equals 0. All right, sounds good to me. 2 objectives. Normally we got 2. Swap back. Students will be able to solve polynomials by factoring and use the distributive property to factor polynomials. 2 different learning objectives, but we got it. So the skill, concept, polynomials. The skill, we will be solving and factoring. So 2 skills in that, guys. But we got a nice one. Got a nice long one, so I'm gonna get this thing started because we're gonna be here and it's gonna be good. So there it is, there it is, there it is. Whew. Good looking handout. First part, factor each polynomial. Guys, we're gonna have quite a few pauses in this one, guys, just because I wanna make sure as you are seeing the work being done and I'm explaining, exactly. You see it, I explain it, sometimes I'm gonna pause and explain a little bit more. So, the word factor, hopefully you already know. We're gonna be factoring, so factors, we wanna make sure we understand prime factorization. So in other words, hopefully everyone here has seen the factor tree or you use the factor tree. If you haven't, you might gonna see one today. But we're gonna go ahead and factor each term in our polynomial down to its prime factorization. So 7x is basically 7 times x. 7 is a prime number. 49 is 7 times 7. Prime number, can't go any lower than 7, right? So what do they share? They share a 7, so I'm going to factor out what they share. I can pull out the 7, and by pulling out the 7, what am I left with inside? I'm left with x for the first term and 7 for the second term, and I am done. Now, of course, I can do a check, meaning 7 times x, 7x, and 7 times 7, 49, check. So you'll see those guys. Number 3, again, first term, 5a squared, second term, negative 15. Yes, negative 15, or minus 15, doesn't matter. But I got 5 times a times a. You notice I didn't say a squared, factorization, prime factorization. And of course, keep them in the minus and then just 3 times 5. So what do you see that they share? The first term has a 5 and the second term has a 5. That's the only thing they share. So we're literally going to take the 5 out of both terms. And when I take it out, that's what I mean by factoring. I'm factoring out a 5 from this binomial. So taking the 5 out of the first term leaves you with just 2 a's, so a to the second. And then, of course, taking a 5 out of 15 leaves me with 3. So, boom, bang, pow. And again, a quick check. 5a squared minus 15. Yeah, that's what I started with. So, number 5, 8ax minus 56a. Same routine, guys. 8 times x times a. Now, I'm going to get a pause here. The reason why I'm going to get a pause is I want you to recognize, well, let's go a little bit further. And then I'll pause. So the reason why I'm pausing, guys, I want you to find what I mean by prime factorization. Number 5 is not prime factorization. Number 5, 8. Well, 8 can be factored more. What goes into 8? 2, 4. So I could break down that 8 to 2 times 2 times 2 times a times x. But I don't want to do that because I know what I'm doing. I know that I'm going to pull an 8 out. There's a whole lot of 2s. 2 times 2 times 2 gives me 8. So again, if I see it, if I can kind of get it, I'm going to do it. So you recognize in the second term, 56 is 7 times 8. So 8 is not a prime number. It should say, if I really am writing them out like I did 1 and 3, number 5, your second term, 56, should be 7 times 2 times 2 times 2. Yeah. That's enough 2s. 2 times 2 is 4, 4 times 2 is 8, 8 times 7 is 56. So we're going to get this thing going. Just wanted to point out that 8 is not prime number, and it could be written out as prime factorization. However, you notice that they share an 8. So you're going to factor out an 8. And they share an A. It's the first time they share a variable. So on the outside of the parentheses, I'm going to put what they share, what they have in common, a common factor of 8A. The first term now has an X, so first term X. And the second term has a 7. So keeping the minus and X minus 7. And that's it, guys. I love it when I have the ability to show my work. Just not writing an answer, I'm writing it out, showing how I came to that solution. Number 7, looks like more letters than numbers. So t squared h plus 3t. So I got a t times h, and then plus a 3 times t. So again, what is it in the first set of products, first term, and the second that they share or have in common? And again, guys, you can see it, and I'm going to highlight it. So it's in there now. And go ahead and show me, thank you, what they share. And of course now, loving the colors because equals. And pull this bad boy out. And when you pull it out, just a T. Because he's got 2 T's, he's only got 1 T. So I can only take 1 T. Can't take out 2 T's. I can only take what they have in common. They only have 1 T in common, right? So remember the check from the beginning, and we're looking good, feeling good. So number 9, right there on the bottom, right? Right down there, I'm writing it out. I'm actually missing an X in the second one there. Let's see how this turns out. So X plus X times Y plus X times X times X times Y times Y. So ideally, guys, I still need, so oops, no big deal though. We're still gonna pull an X out, and we're still gonna have XY. So we do have a mistake in number 9, and the reason why we have a mistake, and this is what I mean by, guys, it's awesome that you're following along and you haven't just jumped to see what the answers are, because that mistake is very clear. We should do a check, and we'll see that it's not right. However, went to number 7, kept moving, we got so many more we need to get to. Let's get it. So guys, you're gonna definitely see the same thing as we're doing the evens now. So our first one, 8m minus 6. First term, 8m, as I said before, guys, 8 is not a prime number. So let's break it down. 8 is gonna give me 2 times 2 times 2 times m. Now, I put the 4, because 2 times 4 is 8. And of course, 6 is 2 times 3. So I knew, and I know that why write 2 times 2 when I'm only going to pull out a 2. So pull your 2 out. Your first term leaves you with 4m, and your second term leaves you with 3. So 4m minus 3. For number 4, 10q minus 25q to the second. My brain automatically sees 5s. So 2 times 5 times q. That's your first term. And then of course the second term, 5 times 5 times q times q. And again, what do they have in common? Well, I got a 2 in the first term, no 2's. I got a 5 in the second term, and I have a 5 in the first term. I got a q in the second term and a q in the first term. So they share a 5 and a q. Pull it out, and what's left inside? And again, guys, feel free to do these checks, right? It's just multiplying through the distributive property. That was the objective, using the distributive property to factor polynomials. So 5 times 2 gives me the 10, so 10q, and of course 5 times 5 is 25, you already have your negative. And of course, there should be a little square next to that q, but y'all get it, we good. 81r plus 48rt. 81 is a pretty big number, double digit, so let's break it down. 81 in prime factorization, what am I looking for? I'm looking for 3 times 3, which is 9, times another 3, which is 18. Hold on a second. Times another 3, times another. So 3 times 3 times 3 times r. Plus, now we got 48. 3 times 3 times 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 don't go. You see that erase? I caught that one. So 48, and here's my factor tree. 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 2 times 2 times 2 times 3. 2 times 2 times 2 times 2 times 3. So again, I was thinking the 3s, I should have been thinking the 2s, right? But write it out, prime factorization. So again, guys, nothing new. Hopefully you're doing factor trees back in the day. And I use my factor tree to be successful in my algebra problem. Building on skills, right? Building on skills. So what do they have in common now? Let's start with the first one. 3 and R. Second binomial, there's a 3, there's the R. So pulling that on the outside of my parentheses, and this is why prime factorization is great. What's left inside? 3 times 3 times 3, 27. Plus 2 times 2 times 2, 16. Now someone that knows the multiplication pretty well, you already know, oh yeah, 3 times 16 is 48. Check. And 3 times 27, that'd be 60 plus 21, 81. Check. So you can do a quick check, using a calculator or whatnot. Number 8, guys, again, quite interesting, whereas, what do we got going on? We recognize and we see a squared, b squared. So that's 2 a's and 2 b's, plus just 1 a. I used to tell my kids, don't make it complicated. If there's only one thing you can take, that's the only thing you can take. The only thing I can take from that second term, a, is a. So can I take an a from the first term? Yeah, it's got 2 of them. So I'm gonna take an a from both, put it on the outside. Now what's left inside? ab squared plus the invisible 1. So even though I took that a away, there still has to be something there, and that's the coefficient in the invisible 1. So time for redemption, number 10. All right, because I made a mistake on the other one. Looks like I'm taking a p out, and there's a quick box answer. Let's see if we can get a quick check in here. P times 3p r squared. Yes, 3p squared r squared. P times 6r, 6pr, and oh, it went too fast. That's why y'all gotta pause it. Pause it and then check. Do what you gotta do. But we got a nice one, guys. So we're gonna be continuing to factor polynomials. Number 10 is a trinomial. Number 12 is a trinomial. Number 12 is actually a polynomial because it has 4 terms, right? So we're number 12, as I guess we did 10, and now we're on 12. So our first term, 10h cubed n cubed. Second term, negative 2hn squared, and the last term, 14hn. So perfect example, or a perfect problem to use the example of writing out your prime factorization. 2 times 5 times h times n times n times n. Recognizing my grouping symbols, the h's got their own, the n's got their own, and of course each constant, coefficient, prime, got its own. So same thing now, 2 times h times h. No, 2 times n. 2 times h times n times n. And then 2 times 7 times h times n. And what do you see? I always tell the kids, start the first one. First term's got a 2. Does the second, does the third? Yes. So get it. And get it. And get it. Next one. Do they have 5? He's got 5, no 5, no 5. He's got an h. So if he has an h, then I can take his h and his h. So get it. And GCF is greatest common factor. Get it and get it. So I got the h's. Now I go to that n. Or can I take another h? No. I'm going to take one h. Because the second term only had one h. What about the n? Can I take an n? Does everybody have an n? Yeah. He's got 3, so I'm taking 1. He's got 2, so I'm taking 1. He's got 1, so I'm taking it. And again, this is why I love this method. Their GCF goes in front, and then you still have your polynomial. And what's left with your polynomial? A 5, 2 h's, and 2 n's, so 5h squared n squared. Second term minus what's left? Just an n. Yep, that's it. And last term, what's left? Just a 7. And that's it, guys. Got multiple colors. My OCD's kicking in because I got a yellow opening parentheses and a blue closing parentheses, but we're all good, looking good. So guys, 14 is the same thing. You just have 4 terms now. And our our coefficients are our numbers that are easy to work with. First coefficient is invisible 1. Second coefficient is -2. Third coefficient is 3. And last, it's not a coefficient, it's a constant, is 6. So the only one that can be broken down is, oh snap, gotta collect like terms. Because the 2 middle terms are the same. Oh, okay. And I see what we're doing. I gotta point out very quickly, let's get a pause in. The reason I'm getting this pause in, guys, is because if you watched our last video, you'll remember that we were multiplying binomials. Or if you watched any video, if you've already gotten into polynomials and you've been multiplying them, you know what happens when you multiply binomial times binomial, you're gonna get multiple terms. Trinomial might even be 4 terms, it ends up being collecting the 2, right? So then it becomes 1, 2, 3 terms because you added the 2 middle terms, right? And so now guys, in this situation where we're factoring, actually going to reverse. So we had 4 terms, 1, 2, 3, 4. We collected the middle 2 terms, which now just gave me 1b. And now guys, I'm trying to figure out, of course, how to get 2 binomials that will multiply to give me b squared plus 1b minus 6. And it all deals with that last term because b squared can only come from b times b. And that's why I've got b for the first term of the first set of parentheses and b for the second set of parentheses. So that's that. B times b gives you that first term of b squared. Now, 1 times -6 is -6. -1 times 6 is -6, but there's other options. So I'm trying to what's called guess and check what the next 2 values are going to be in that binomial times another binomial. So I know it's b plus something and b plus something. Maybe it's b minus something and b minus something, but that's what we're figuring out right now. So there's so many different ways to do this, guys, and I'm excited to see what the Bearded Math Brothers going to do to get this one. See it started. So I'm figuring out all the different ways, I guess, that I can get -6. I can get -3 times 3. -2 times 3. Sorry about that. Or I can do +2 times -3. Now, believe it or not, I'm walking on air. Somebody go get that over your parents and watch.
Suddenly I'm up on top of the world. It should have been somebody else. Believe it or not, I'm walking on air.
Anyway, believe it or not, those are the only ways you can get -6. So when I add those 2 values, 1 and -6, I get -5. -1 and +6, I get +5. But when you add -2 and 3, you get +1. I like that. That's the middle term. That's what I need. Remember that foil? Maybe not, you didn't watch that video, but it works out, guys. So I literally was guessing and checking to see how I could get the 2 terms that are gonna make that trinomial work out. Now, that was actually not the factoring method that, we were doing earlier. It's a different technique. But watch me check it. B minus 2 all times B minus 3. So here's my box. I call it a box. It has a technical name. You don't have to be technical here. It's good to be technical. Oh, not here right now. So B minus 2 on top, B plus 3 on the bottom, and B squared. -2B, 3B, and -6. So boom, matched. Boom, matched. Boom, matched. Boom, matched. So I got it. That's what I started with. And that's what I get. So I got different technique. the whole factoring sense, it's good, but what we're doing here, guys, is we're using a different technique. So it's gonna make sense a little later, but right now, guys, if there's 4 terms, this is what I like to do. Now, if your teacher says, well, you need to group them and factor them, say, okay, show me. And they'll definitely be able to do that, but I'm sticking with BMB. So, number 16, again, I want you to learn this technique. And of course, you know how to factor because we did that. So factoring, and also now, guys, I know 2 binomials that are going to multiply to give me 2a squared minus 3a minus 2. Now watch how I factor. So here it is where there are 4 terms that we started with for 16. I've got 4 boxes. First term, last term. Now what's cool is, see that 3rd term and the 4th term? There it goes. I got 4 terms, I got 4 boxes. I just filled them in. And I'm going to factor out again. So now I'm thinking as I'm working this out, what multiplies to give me 2a squared? Well, 2a times a. And then how do I get a? Well, 1 times a. All right, I'm still just working out this. And 2a times negative 2 gives me negative 4a. So that checks. Boom. And then, of course, 1 times negative 2 is negative 2. Boom. I just used the box to figure out the 2 binomials. Now, yes, repetition. That's why we got a whole lot more to do, guys. But you're going to recognize as we continue to go that I don't have to do the check because the check's right there. Before, you saw a different technique where we used the box to check it, but for this guy, I did the box, so we feel good. Now, 18 again, 4 terms. First term, 9x squared minus 3xy plus 6x minus 2y. Now, this is where I stop and I breathe and I go, they are going to try you. That's their job. They want to see what you know, how well you know it. So let's get some room, because I'm going to need the room for this one. And what I would like to do, guys, is again, recognize for 18, how many terms are in your polynomial? Very good. There's 4 of them. Since I have 4 terms, my brain thinks, well, let me use this box again, because the box will hold all 4 of those terms. And let's see if I can figure out. And again, this isn't the only way, but it's the way that I'm showing in this video. So the last term and the first term, they go in the first box and the last box, right? Then my middle terms, they go on the diagonal. So here it is in the diagonal, my brain starts thinking, all right, now what multiplies to give me what I need? Well, I think I know. For the first term in the first box, second term in the second box, third, all right, yeah, we talked about that. But here we go. So to get that first term, or maybe to get that last term, but I do want to, there it is. How do I get, there we go, 3 times 3 and x times x. But now I just need a negative 1y and I get what I need in the second box. Now what do I need down here though? 3x times what gives me 6x. You got it. And then of course I look and I go, hold on, 2 times negative 1y is negative 2y. And I go, that was easier than I thought. But of course it was easy because I was here doing it with you. But you'll pick this up. We've got some more to do. We actually have some solving that we gotta get done. But please, definitely spend some time on this. It's a skill that is going to arise and come up as you continue. And factoring, as we were doing it way back when, factor trees, it's a form of factoring. We're using and building on that skill as of now. So here it is, finally. I think we are going to have to get something up here to do. What are we gonna do? Oh, we're gonna do more factoring polynomials with 4 terms. So x squared plus 3x plus x plus 3. And again, there's a grouping method. And yeah, wasn't in the mood for it. Put it in the comments. I'll come back to this handout again. But I like to, common sense, collect your like terms. You get 4x. What multiplies give you 3, but adds up to 4. That's how we get it, guys. So you're gonna see more and more of that. There's especially some of the other earlier. We did it earlier with factoring simple trinomials, complex trinomials where your a does not equal 1. And if this sounds like gibberish, go back and watch another video. 15, 2j squared plus 2j plus 3j plus 3. Again, guys, when we do it works. Collect the like terms and then figure it out. Now, this one is just not j times j because there's a 2 in front. So 2j times j can't give me 2j squared. But how do I get 3? Well, 3 is a prime number, 1 times 3. So I've got what I need, but is it right? Let's find out. 2j times j. I'm gonna do the box. I'll do the box. If you haven't realized yet, I did the box. 2j plus 1 and j plus 3. So 2j squared, 1j, 6j, and 3. Now here's what I'm recognizing. Hold on a second. Is that right? I don't think so. 2j squared plus 7j plus 3. Well, we've got a problem, guys. 7j is not 5j. Did I know this was going to happen? You know I knew it was going to happen. I know it was going to happen. So what we got to do? We got to fix it. We got to fix it. And when I say fix it, it's not correct. So let's take another look at it. If I need my middle term to be 5j, well, again, guys, let's take a look at the box. This is what I was saying when I talked about understanding the factoring, how the box works. What's on the outside, how we got what was on the inside. Well, now we got stuff on the inside, we're figuring out what's going to be on the outside. So 2j squared, 2j, 3j, and then 3. Now watch and realize again, 2j times j is your only choice. But recognize that 2j and 2 share a 2, don't they? Yes, they do. Yes, they do. So in my mind, that works out pretty well. Now the bottom one, I see 3j and I see 3. Well, again, they share a 3, so I can factor out what? 3. I'm factoring out the 3. So now, of course, let's figure it out. 3 times what gives me 3? Of course, 1. 2j times what gives me j? Okay. So again, let's check it. And this time when I do my check, I see my middle terms and I start to smile. You start to smile with me and you go, man, Mr. Kraft. Yeah, that's it, Mr. Kraft. Beard Kraft, brother. That was easy. Well, it's easy after the repetition and after the understanding, right? So now my 2 middle terms are gonna add up to what I need, which is 5j, and I'm comfortable with my answer. Love it. So getting it in there and getting it boxed. And maybe I'm not gonna box it. But again, guys, not the only method. We start off with factoring. So there is a technique where you will group your first 2 and your second 2, factor out. I'm sure that'll come up later on. But for now, guys, I'm staying with my tried and true factoring using the box. So 6t squared minus 4t minus 3t plus 2. What's my technique? How do I want to attack this problem? How do I want to approach this problem? Well, I love the box. So 6t squared, first term, negative 4t. All you gotta do is forget the minus and everything's gonna go all right? So negative 3t and of course the positive 2. And now what I'm doing is I'm trying to figure out what goes on the outside, right? So I'm factoring out. What goes into 6 and 4? 2. And if they both have t's, I can take a t out. So I factored out of the first top 2. Now I'm factoring out of the bottom 2. What goes into 3 and 2? Nothing except for 1, right? Now I factor up. What goes into 4t and goes into 2? 2. 2 goes into 2. 2 goes into 4. Now what goes into 6t squared and 3t? What do they share? They share a 3. This is going back to the prime factorization and we're saying 2 times 3 times t times t. Well, I'm not writing it out this time. I'm just know that I can pull a t out. Ooh, see that check? I needed a negative. So the red negative in front of the blue 1 is making sure that when I am getting a final answer, it is working out. The box is what will work it out. Because I just did a check and I'm feeling comfortable. So guys, this is what I tell my students. It's not hard, it's just challenging. Separates the men from the boys and the women from the girls. Young women, young boys. Wait, said that wrong. Young women, young men. All right, guys, let's see what we got. So, like I said, guys, we got a nice long one. We're already getting past the 25-minute mark, but it feels good because we're learning, and I hope you're learning. I know I am doing my best to give it to you. Solve. Oh, no. Nah, not that hard, guys. First thing I want to recognize is zero product rule. Pause. Now, I have to pause because if I say noun, yeah, person, place, and thing, yeah. If I say action word, verb, yeah, ing, yeah. Jumping, swimming, right? So there's certain things you just know. What's your odds? Huh? Okay, evens, 2, 4, 6. So I need you to know the zero product rule. Any two things being multiplied by 0, any two things that are multiplied that equal 0, like A times B equals 0, either A is 0 or B is 0. I hope I got some graphics help me out with this. That's what I know I do because I got great editors. 2 times X equals 0. Well, 2 times what equals 0? X has to be 0. When you multiply and the answer is 0, something better be 0. Something has to be 0. That is what the zero product rule is. So literally, if I see parentheses and another parentheses, I know they're multiplying. Because when parentheses touch, it means to multiply. And if it says equals 0, zero product rule. Got it. It's done. So with that, guys, that's all that's happening here. And it starts off pretty straightforward. I'm going to explain it. Let's get this bad boy moving. Now, what we're seeing and what we got is the answer already. How do I know that's the answer already? Well, it's the answer because X either has to be 0 or that second parentheses of X minus 8 has to equal 0. So I literally set that up, guys. I set up 2 equations. The first equation, I didn't do anything. It was X equals 0. The second equation, though, X minus 8 equals 0, that's a 1-step, guys. So now I'm plugging in to check, right? If X equals 0, there you go, right? 0 times a negative 8 is 0. It checked. Well, in the other, let's say X is actually 8. So I'm going to have 8 times the quantity of 8 minus 8. Plug it on in. Come on, plug it on in. Plug it in. There we go. 8 times the quantity of 8 minus 8. So now it's 8 times 0. What's 8 times 0? 0. So again, guys, I like it because you see it, you understand it because you know anything times 0 is 0. But we definitely got to understand it in terms of factoring, solving a polynomial, using the zero product rule, all those great things. So here's what I was talking about where I have a binomial times a binomial, but they equal 0. So take my first binomial, m minus 3. Well, that has to equal 0. Or what's inside the other parentheses, m plus 5 must equal 0. Because that's the zero product rule. Solve my first 1 step, m is equal to 3. Solve my second 1 step, and m is equal to, going a little fast, negative 5, right? Looking good, feeling good. And of course, another quick check wouldn't hurt, but I believe you guys are understanding the concept, and if not, just take a quick pause, rewind a little bit maybe, and listen to that 0. Oh, spoke too soon, there's my check. So, bracket, parentheses open, parentheses close, minus 3, bracket close, bracket open, parentheses close, plus 5, bracket close equals 0. That's me reading it. Fill in the parentheses. So 3 goes inside. Of course, there it is. 3 minus 3 is 0. 0 times anything is 0. So 0 times 8. And of course, what about my other value? Well, plug it in. And I love it because you do it the exact same way we did it before, right? And now plug in your second value for m, because you can have more than one value, and you're seeing that now. -5. So -5 minus 3 is -8. And of course, -5 plus 5 is 0, so anything times 0 is equal 0. And it's checked again, right? So I really enjoy when you have the opportunity to see it and it makes sense. But if it doesn't, that's what we like to call a POC, a point of confusion. So at 25, there's a point of confusion. It doesn't equal 0. And since it doesn't equal 0, what are you gonna do? Tell me what you wanna do. I know what I wanna do. I wanna make it equal 0. Guys, that's the whole goal. The goal is to make it so that you can use the zero product rule. So let's make it work. We're gonna change 25 by simply rewriting the equation using the inverse operation. Because, all right, we gotta get all this stuff out of here, man. There it is. Finally, ready. 25, 3a squared equals 6a. What's the opposite of 6a? The inverse. Opposite. -6a. So I'm literally going to subtract 6a from the right side and subtract 6a from the left side. And when I did that, you can kind of see now that it's 3a squared minus 6a. And we go back to what can I factor out? Well, I can take a 3a from the first and the second term. That's why it's on the outside of the parentheses. So now 3a parentheses a minus 2. So of course 3a must equal 0. Or a minus 2 must equal 0. And again, guys, without me, and you know I will, because I'm supposed to, and here comes the beauty. So the first thing I did was subtract 6a from both sides, subtract. When I subtracted 6a from both sides, then I was able to factor the binomial. And when I say factor, I pulled out the greatest common factor of the two terms, which was 3a. Then I used ZPP, zero product property, meaning either 3a equals 0 or a minus 2 equals 0. And then, of course, I solve those two equations. And here comes my check. So in the check, start with the original equation, 3 parentheses squared equals 6 parentheses, plug in 0 because, of course, a can equal 0 or a can equal 2. Got a good check for that. But now, check my other solution, which is 2. And it looks like, come on now, there it is. Get it. Got it. Plug in the 2. And this is where I'm like, hold on, is this gonna work? Is this gonna work? 2 times 2 is 4, 3 times 4 is 12. Oh, and 6 times 2 is 12. We got it. All right, guys, so I would not be surprised if you wanted to go back and watch that again, but we're gonna keep on moving, guys. So, that was 25, and looks like we are going to take care of the last half of this, last section of this. We've got 1, 2, 3, 4 more, identical to the last few. So 20 starts us off easy in my opinion because I don't have to do the factoring. The B is already pulled out. So some kids will see that, see the distributive property and make it B squared plus 12B. And I'm like, no, that's not what they want you to do. They want you to solve for B. And they've already began that. So B is equal to 0 or B plus 12 is equal to 0. So therefore B is equal to -12. Got it. And again, guys, plug into the original problem, the original equation to do your check. For 22, this time you get your first and your second, right? So literally it's set up, take that first parenthesis, set it equal to 0. And what's cool is, guys, you can literally draw a little swiggly to show case 1, case 2, of equation 1, equation 2. Showing your teacher that you automatically know, of course I gotta do both of them. It's zero product property, right? So, not showing the inverse here, and not even showing the two-step, but subtracting 1 from both sides. Oops! That's what I get for going fast. But hey, it took, what, 28 minutes almost, 30 minutes for me to make a mistake? It's okay, guys. It should be a -1/2, because when I subtracted 1 from both sides, it should have been -1. But those things happen. Mistakes. Now, my boss don't like it when I make mistakes, but he cool. So, 24. Wrapping it up, guys. We pulled a y from the y squared, and we pulled a y from 3y. So again, earlier you saw when we would use the distributive property to check, but we didn't check it, we just factored out. And then of course, y is equal to 0, or the binomial y plus 3 is equal to 0. Y plus 3 is equal to 0, subtract 3 from both sides, and you're feeling and looking good with y is equal to -3. So that's what I'm feeling about this one, guys, with 26. Remember, this is the one where you need to set it up. So if it doesn't equal 0, make it equal 0. Subtract 3x from both sides. Now I'm looking at it going, remember when I used to say 2 times x times x minus 3 times x? Well, not anymore. I just recognize that the only thing I can take from the first and second term is an x. So the x is on the outside. And then of course, here's my zero product property, where either x is equal to 0 or the quantity 2x minus 3 is equal to 0. And we're solving that. And much better this time, guys, because when I add 3 to both sides, I get a positive 3 divided by the coefficient of 2, and x is equal to 3/2. Guys, we've gone over the 30-minute mark. Might be getting close to the 40-minute mark. You know what I like to do? I like to give you my best. And if it's 20 minutes, it's 20 minutes. If it's 40 minutes, it's 40 minutes. If it's over an hour, I'm going to have to take a break. Thanks for watching, guys. See you in the next video.